So what are we working on tonight?
Law of sines.
Law of signs?
Law of sines and law of cosines.
Okay. You got some specific problems that you want to do?
I mean, I do have problems, but I think I need more of an explanation first.
Okay. Here's what the law of signs says. It's in any triangle, the relationship between an angle and its opposite side is the same, always. In other words, the ratio of the sine of the big angle A divided by its opposite side, little a, is equal to the sine of the big angle B divided by its opposite side, which is also equal to the sine of the big angle C divided by its opposite side. That's what the law of signs says.
And so that ratio is just equivalent.
That ratio is constant within any triangle. Okay. In other words, if I gave you a problem such as the following, let's say I gave you that angle, 40 degrees, and I gave you that side. And then I give you this side there. Okay? I've given you 3 pieces of information. I've given you 2 sides and 1 angle. Using the law of signs, you can figure out, you can solve the triangle. Because we have that right there. We know the sine of 40 divided by 7 is the fundamental constant for this triangle. And I can solve for the sine of B. And once I have the angle of B, I'll know the angle of C, and then I can solve for the side of C. So you only need 3 numbers. In fact, let's go through this. Let's solve this problem.
All right.
Tell me what I should write next.
Well, sine of 40 over 7 equals sine B over 5.
Okay, next step.
You cross multiply.
You don't really need to cross multiply, but you do need to multiply both sides by 5. In other words, cross multiplying is a little self-defeating because you would have to divide both sides by 7. So there's no point in cross multiplying. But this is the next step. Okay, now come up with a number for that. You have your calculator?
Okay.
Now figure out what B is.
Would I do the
Inverse sine of 0.459.
It's 27.33.
Now, in actuality, B could be one of 2 different angles. It might also be 152.67 because the sine is positive in both the first and the second quadrants. Now, could B be 152.67?
No, because that's the other.
Right. We know that this triangle has a 40-degree angle in it already, so it does not have any room for 152. So I cross that out, but that is the way to handle the ambiguous case of the law of sines.
No.
Always come up with both angles and then see if one of them fits. If one of them fits, then you have two solutions. If this, go ahead, what? If both of them fit, then you have two different solutions. You have two different possible triangles. That's why it's called the ambiguous case. We'll do one here in a second that I happen to know works. Okay, let's finish this one though. So we get B is 27.33 degrees. What's that make C? What's that make angle C?
It's 112.6.
All right, we won't worry about the decimals. Now we've got 5 pieces of this triangle solved. How do I solve the 6th piece?
When you got 27.33, you always get the other angle possible by subtracting that from 180.
Yes, always. Let's make that 27 or 28. I'll round it up. I don't want to deal with all these decimals. Okay? So once you solve for angle B, then you can figure out angle C. Now how do I solve for side C?
You can just do...
Remember, is all we need is one fixed relationship. And we actually have 2. Choose either one.
Yeah, you would do just sine A,
which is 40,
over 7 equals sine of 112 over...
Correct. And there's only one variable in that. That's C. Okay. Now here you could cross multiply if you want. You get sine of 40 times C equals sine of 112 multiplied by 7. So C equals 7 sine of 112 divided by sine of 40. That's what C is going to be, the side length. Okay. Now, this was not an ambiguous case. Let me give you an ambiguous case. This triangle has 3 parts that I've given you. Solve it for the rest of it.
Okay. So, sine 30 over 8 equals sine C over 10. And then 10 sine 30 over 8 equals sine C.
Sine of 30 is 1/2. So we got sine of C equals 5/8. Tell me what C is. Let's just leave it at 38, okay?
Yeah.
These decimals don't do anybody any good. We'll leave it at 38 degrees. What's the other angle that C could be? And this is the necessary step you want to do every single time.
140.
Now, does 142 fit?
Yeah.
It does. So I actually have two different triangles that will work here. One of them looks like this, where that is 142 degrees. I still have 30. That leaves 8 degrees for that one right there. And this triangle up here is 38 degrees there. That's 68, so 112 is that angle. Now, notice what both of these things have in common. They still have a 30-degree angle. That's still 10. That's still 8. In other words, it is still side-side angle, or angle side-side. In other words, when you have an angle side-side, sometimes that can be two different triangles. There's one, there's two. And it all comes down to whether this second angle over here fits in the triangle. In other words, the only thing we know about this triangle is that it's got a 30-degree angle in it. Well, the 38-degree angle for C certainly fits, but so does the 142. And you end up with two answers, that one and that one. In other words, the only information I gave you was an angle, a side, and a side. And right off the get-go, I don't know whether that's going to be an ambiguous triangle or not. The only time I find out is when I get to this point right here and I figure out that second angle is 142 and it fits. If it had been 152, it wouldn't have fit. And I would cross it out and it wouldn't be in the ambiguous case. And the ambiguous case of sines is really the only tough part of the law of sines. Everything else is easy. The law of sines is really one of the easier things in trig, except for the ambiguous case.
And that's the only part of the law of sines?
That's the only hard part to the law of sines, if you ask me. I mean, every other situation is just plugging it into the formula. You got the sine of A over little a equals the sine of B over little b equals the sine of C over little c.
Yeah, I didn't think you taught us that the ambiguity, yeah.
All right, let's talk about the law of cosines.
All right, that's also law of sines?
Well, that's the only hard part that I know of the law of sines is the ambiguous case. Every other problem with the law of sines is pretty easy. Now, here's the thing. The law of cosines always requires you to finish it with the law of sines. So when you use the law of cosines, you only use it to begin the problem. You don't use it to end the problem. Now, the law of cosines basically is when you have a situation like this, where you have side, angle, side. Notice what you're missing. You do not have an angle and its opposite side. In other words, I cannot begin that with the law of sines. In order to use the law of sines, you've got to have at least one angle and an opposite side. And you don't ever have that if it's side, angle, side. Okay? So this begins with the law of cosines. What's the law of cosines say regarding this triangle? We start out with little a squared equals what?
I'm not sure.
Well, here, let me give you the general formula. Starts out a lot like the Pythagorean theorem.
Yeah.
Whoops, not AB, but BC. Cosine of A. Now, there's actually 3 laws of cosines. Let me write the other 2, and you can figure out the pattern. Notice what I'm doing.
Yeah.
So what's this one?
C squared equals A squared plus B squared minus 2AB cosine of 6.
Okay. So, depending on the situation, you choose one of these 3. Well, I know B and C, so I'm going to solve for A. So I'm going to use the first equation. Now, plug in everything. A squared, that's what we're solving for. What's B squared?
64.
What's C squared?
49.
Minus 2 times 8 times 7 times cosine of 75 degrees. Notice that everything on the right side is a number.
Yeah, so I can
So A equals the square root of all of that. So let's come up with A. Got 113 minus 56 times 2, 112. What's cosine of 75 degrees?
0.258.
So what is A?
What is that saying? What is 8 times 7 there?
Well, that's 112. In other words, I've done most of the legwork. Just finish it for me. What's 113 minus a quarter of 112? Something's wrong.
It's
Hold it.
84.
Yeah, that doesn't sound right.
Yeah, it's not.
Now, hold on. A squared equals B squared plus C squared minus 2BC cosine of A. So that's 64 plus 49 minus 2 times 8 times 7. This cosine is 75.
Cosine of 75 is 0.258.
Okay, what's 0.25 times 112?
28.98.
That gives us a side of like 85. That doesn't make any sense.
Yeah, 64.
No, that doesn't make any sense. What did we do wrong here?
I have that same formula written down from the other day, so I think that's the right formula.
Yeah, we got the right formula, don't we?
Yeah.
Ah, it's A is the square root of this. What's the square root of 85? That's what our problem was. What's the square root of 85?
Where it is 9.16.
Alright, that's what A is 9.16. That makes much more sense. Okay? Now, notice we still have not solved the triangle. We've got all three sides, but we only got one angle. So how do I get the second angle? You always have to finish these with the law of sines. In other words, now that I've got an angle and its opposite side, now I can use the law of sines to finish it.
Yeah. So sine of 75 over 9.16 equals sine of B over 8.
Okay? What's the next step to solve that?
8 times sine 75 over 9.16 equals sine 8.
Okay. What's B? In other words, go ahead and give a number on that. What is it?
B is 4.8.
Hold on. Let's first of all figure out what the sine of B is.
Sine of B is 0.084.
Don't think so. Don't
Sine
think
is
so.
91.16.
Sine of 75 degrees is close to 1.
Yeah, I typed that.
So what's 8 times the sine of 75 degrees divided by 9.16?
It's 0.84.
Okay. Now you can figure out B.
Yeah.
What's,
So we use second sine and second cosine. Just sine.
what's that?
We're using law of sines now.
Whenever you have a problem that requires you to start with the law of cosines, you necessarily end with the law of sines. Always. So there is no problem that requires the law of cosines the whole way. There are only two types of triangles that require you to start with the law of cosines, and I'll get to the next one in a second. But let's finish this problem. What is B?
57.5.
Now, notice that I don't need to use the law of sines to solve for C. I've got two of the angles. What's angle C?
It is 47.48.
I've solved the triangle. I got all three sides and all three angles. And I had to do it using the law of cosines first, then the law of sines, and finally, I could have used the law of sines to calculate that angle, but that's not the easiest way to do it. The easiest way to do it is just to subtract from 180. Okay? Here's the only other situation where you have to use the law of cosines. That's where you have side, side, side. Okay? Let's go through this using the law of cosines. Tell me what to write.
Is it the same formula?
Well, it's one of those three formulas, and you actually have your choice of whatever side you want to start with. Pick a side.
I would do a squared equals c squared plus c squared.
Hold on. 8 squared equals 6 squared plus 7 squared. What's the rest of it?
squared equals 6 squared plus 7 squared minus 2h times 8.
It's always the same two numbers. It's always the same two numbers. The 8 is the only thing stays on the left. On the right, you got nothing but 6s and 7s. Times the cosine of what?
Cosine of
B. That always matches the opposite angle to the 8. In other words, whatever side is on the left side. This was side little b, right?
So we did the b squared equals a squared. I had it backwards.
We had b squared equals a squared plus c squared. It's always the other two variables. Times 2 times a times c times the cosine of capital B. That's the general formula.
Yeah, I understand.
Okay. Now, when we fill it all in, let's calculate what this is.
So 64 equals 36 plus 49 minus 14 times 6, so 84. Cosine of B.
Now, notice what the unknown is. The only unknown is that. Everything else is a number. So I'm going to be able to solve for B. Okay, let's do it. We got 64 equals 85 minus 84 cosine of B. What's the next step?
Would you get it on one side?
What's the next line in this equation to solve for B? Same with every equation. You're always trying to isolate that. That means you got to get rid of anything else that's with it.
So first you subtract the 85.
Okay, that makes minus 21 equals minus 84 cosine of B. What next?
Well, you could get rid of the negatives.
Okay.
And that, there's 21, 84 equals cosine of B.
Yeah, that happens to be 1/4. Now, what's B equal to?
So, second, inverse tangent of cosine.
Not tangent, inverse cosine.
Inverse cosine of 1/4.
Okay.
75.5.
75 degrees. That's what B is. Now, notice what we have. We have a triangle where we have an angle and its opposite side. That means I can finish solving this triangle using the law of sines. And that's always the case. So give me what I should write.
Sine sine 75 over 8 equals sine of A over 7.
Okay, again, that's the only variable. So I get the sine of A equals 7 sine of 75 divided by 8. What's that number?
0.845.
And what is the angle A?
57.7.
58 degrees. Now, I'm almost done. I still haven't solved the triangle. What's the last step?
We gotta find the angle of C.
Okay, how do I do that?
You just add them up then subtract it from 180.
So that's 133. That's got to be 47. That's how you solve. Now, let's go back and review. The only two cases where you have to use the law of sines is when you have side, angle, side. Notice why I've got to use the law of sines. I do not have an angle and its opposite side. I have three pieces of information, but that's not enough. So I got to use the law of sines, law of cosines here. And the other situation is where you have three sides. When you have three sides and no angles, you got to use the law of cosines for that. You got to use the law of cosines for that. Both of these, and this is the only two situations where you got to do it. And both of these, the very next step is to use the law of sines. So you're always using the law of sines also. Whenever you use the law of cosine, at some point in solving the triangle, you got to use the law of sines. Okay? Just remember that the only are side, angle, side, that's this one, and side, side, side. So whenever you have side, angle, side, or side, 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 you got to start it with the law of cosine.
Okay.
All right, Max, you got any last questions?
No, that was really helpful.
Okay, good. You have a good day. I'll talk to you next time.
Yeah, thank you.
Bye-bye.